Welcome to Tech Teach.
Signal transmission is basically of two different types. Okay, so one is called baseband transmission, another is called basically the passband. These are not that much important, but yeah, you should be knowing the basics about it. So if it is baseband, okay, so what is the meaning of baseband and what is the meaning of passband? We will just see one by one. So here this is a system. It is sending a digital signal, and that will be sent through a channel. Through a channel, the signal is going, and it will be going to the receiver. Okay, so this is the transmitter, and this is the receiver, and the signal will be going through the transmission medium. So that is called the channel, basically. A digital signal is a composite analog signal. Composite analog means the analog signals that are having different components. So like there is one analog signal, this is another analog signal can be like it is having, this is the another analog signal with the same frequency but different amplitude. Another can be having like analog signal with different frequency itself. So if more than one analog signal is there in two or signal, that will be considered as a composite analog. So digital, if it is a composite analog, its frequency domain representation will be like a continuous one. It will be like a continuous in frequency domain that we have just seen. So this is the continuous as given by here. It is a digital signal. Its frequency domain is like continuous in nature. Or if a composite signal is there, its frequency domain is continuous. So that's why the a single digital signal will be considered as a composite signal that is made up of analog signals basically, and it will be having infinite bandwidth. So because it is ranging up to going up to infinite, so starting with 0 up to infinite, so that means this will be the bandwidth. So that's why it is saying like it is having infinite bandwidth. So if a digital signal is there, it will be having like an analog signal and it will be having infinite bandwidth. Bandwidth can be of like two different types here basically being considered. So one is like wide bandwidth, another one is narrow bandwidth. So what is the meaning of narrow and wide bandwidth? So bandwidth in the sense like the range of frequencies basically. So if wide bandwidth means frequency ranging from 0 to f1 is there, but it is having a higher gap. This gap is very high, so it will be like wide bandwidth. So this gap is bandwidth is given by like high frequency minus low frequency. So if f1 is higher and lower is 0, then it will be like the wide bandwidth. If it is narrow bandwidth, so here this f1, f1 dash if we talk about, so here f1 is much greater than f1 dash basically. So this is the case. So here this is the narrow bandwidth. So narrow bandwidth means it is having very less space or less number of frequencies through which the data transmission will be taking place. If wide bandwidth means large number of frequencies are there, so that will be the wide bandwidth. It is like two low pass channels. So channel is there. First of all, channel. What is channel? Channel is just we have seen. This is the channel. Channel means through which the data will be transmitted. The medium through which the data will be transmitted. So that will be a channel. So channel can be of like a low pass channel. So low pass channel means you might be knowing like what is low pass filter. So in case of filters, we know like this is the frequency. So if it is a low pass filter, so it at low frequencies it will be having a high gain, and at high frequency it will be having the zero gain. So this is called like, this is basically the gain. A is gain basically. So that means whatever the signal we are transmitting, it will be having low frequency, then it will be allowed to pass. If it is high frequency, it will be not allowed. It will be becomes 0. The signal becomes 0 at high frequency. So this is low pass filter. Okay. Similarly, if it is high pass filter, so for high pass filter means for high signals it will be passing. So for high signals it will be having the high gain. Otherwise it will be having the zero gain. So this is high pass filter. So it is low pass channel. In the sense, the channel is low pass means it is allowing low frequency to pass. So that's why low pass channels will be starting with its bandwidth will be starting with zero to some frequency range. So this is again starting with 0 and then going to some frequency range. That's why it is called low pass channel. In the low pass channel, there will be like two, wide band and narrow band. Wide band means it will be allowing large number of frequencies to pass. Narrow band means it will be having less range of frequencies so that the signal can pass. So if a medium is there, so it is going to say like here, wide bandwidth channel is there. So wide bandwidth means having high bandwidth, okay? So high range of frequency. Input signals are considered as the baseband signals. So baseband signals in the sense, so it will be having a bandwidth ranging from the starting 0 then to a particular frequency. Okay, so this is the baseband signal. So like a single digital signal is there, so it will having the range of frequency starting with 0 to some frequency or infinite values. Okay, so that is the input signal. So this is the input digital signal. Its bandwidth is given by in frequency. This is the time domain, and this is the frequency domain representation. So in time domain, it will be likewise. In the frequency domain, it will be likewise. So this is the bandwidth of the signal, input signal, and this is the bandwidth of the medium. So bandwidth supported by medium. So medium is like whatever the medium is there, the wires are there. So wires will be supporting a limited number of frequencies. So its bandwidth will be given by starting with frequency f1 to frequency f2. So this is the range of frequencies that can be allowed to pass through this channel or through this wire. So once this signal is passing through this, after passing through it, at the output we will be obtaining the output that will be the result of multiplication of these two signals. So if signal 1 is there and signal 2 is there, this will be multiplied and the output will be this one, having the bandwidth like in between 0 to infinity. Somewhere here, suppose there is f1, somewhere here this is f2. So once it will be passing, it will be multiplied, and only the f1 and f2, in between f1 and f2, whatever is the value, that will be reflecting here. So f1 and f2, the output will be reflecting. So at the output we should be getting this signal because this is the input. So this input should be available at the output because we are sending the input to the receiver side. The receiver should be accepting the same thing, but it is not accepting the same thing. It is going to get some different value. So this different value is because we are neglecting or we are removing basically this frequency range, because once we multiply these two, the values of the signal in this frequency range are going to be 0. So once it is 0, then we will not be getting the exact output. Exact output that similar to the input. Input is likewise, but we are not getting the exact output. You can just see it into time domain. So it is having some distortion, some modification in the input signal is there, that is at the output end. So output signal is different from the input, but it is almost similar to that, but there is some distortion in that. So this is considered like whenever we are sending a signal through a channel, whatever the channel bandwidth is there, that will be playing important role to receive the signal at the output end. So whatever signal we are receiving, that will be depending on what the channel is there. What is the bandwidth of channel? If the bandwidth of channel is high, then whatever the signal we are sending, the same signal will be received. But if the bandwidth of the signal is not high, it is a band limited or it is having some specific band, then some of the frequencies will be removed. So we will be getting some distorted output. From this distorted output, we should be again reconstructing this input signal. So this is how basically the transmission takes place. That is the baseband transmission. So baseband transmission means the baseband means starting with 0 to some frequency. So this is if any signal is there that is having the bandwidth starting with 0 to some frequency, then that will be considered the baseband signal basically. So baseband transmission means we are transmitting a signal that is starting with 0 to an signal to a frequency that is here infinite is there. This is the ideal case basically. So to a frequency f is there, that will be baseband. So we are transmitting baseband signal using a medium. So we will be getting not the exact output, we will be getting some distortion, some modification, some error will be there at the output, but we will be able to recover this from the data that we have obtained. So by this signal, we will be able to get the output. In practical, this happens once we send the data. So baseband transmission of a digital signal that preserves the shape of the digital signal is possible only if we have low pass channel with infinite or very wide bandwidth. So it is saying like we will be able to preserve the input signal. We will be able to preserve the input signal only when this channel is there. So this channel is having infinite bandwidth, but it is in this case it is having f1 to f2, means f2 minus f1, high to low. This is the bandwidth. Only this is the bandwidth. It is not infinite. If the channel bandwidth is infinite, here it is saying like if we have a low pass channel with an infinite or very wide bandwidth, then only we will be able to preserve the shape of the input signal. Input signal that we are transmitting, the shape will be preserved if the channel bandwidth is very high or wideband channel is there, or it is having infinite channel. But practically it is not possible. Okay, so that's why there will be some distortion. If we want to send the data at a faster rate, then we should be having higher bandwidth. If we are having higher bandwidth, means we will be able to send more amount of bits per second. So that is basically going to say like bit rate should be high. Means if we are it is saying like if we want high bit rate, so bit rate is basically proportional to bandwidth. It is what it is saying. So if we want higher bit rate, we should be having higher bandwidth. So baseband channel was like low pass channel. Low pass channel is nothing but the baseband channel. Baseband channel means its bandwidth will be starting with 0 to a particular frequency. So starting with 0 to a frequency. So here bandwidth will be given by f higher frequency minus 0 lower frequency. So f will be the bandwidth. This is case of low pass channel. But there is band pass channel. So band pass channel will be like it will not be starting with 0 frequency. Okay, so it will be starting with a specific frequency f1 and it will be going to f2. So the bandwidth in this case will be given by f2 minus f1. This is the bandwidth in case of band pass channels. So if the available channel is a band pass channel, we can't send the digital signal directly to the channel. So we can't send the digital signals directly because the digital signals are having the frequency component or the frequency spectrum is ranging from 0. Okay, so it is ranging from 0 to some frequencies. In case of we are talking about the signal transmission, that is basically for digital signal. So digital signal can be a periodic type or can be a aperiodic type. So if it is a periodic type, its frequency is basically like at f frequency it is having some component, then 3f likewise the frequency is going to increase. At different frequencies it is having different components. Okay, in frequency domain. If a single non-periodic type of digital signals are there, because in case of previous lecture we have just gone through, like in case of signal data transmission, we use non-periodic type of digital signals and periodic type of analog signals. So in case of this data transmission or data communication, basically we will be using aperiodic type of digital signals. So if aperiodic type of digital signals will be there, its frequency component or in frequency domain, it is given by like starting with having frequency 0. At frequency 0 there is high component, then at each frequency there will be some components will be there, some amplitude will be there. Okay, so starting is the 0, starting with 0. This is the case. So if this is the case starting with 0, and if we want to send this signal, if we want to send the signal, so this was the band channel bandwidth, and our signal bandwidth is the previous that we have just gone through. It will be like an analog signal. Okay, so this is the frequency and this is the amplitude. This is the amplitude. So it will be starting with zero frequency and going up to some frequency or up to infinity. It will go. So if we are transmitting this, this is the signal. This is the basically digital signal basically. So if we pass through it after multiplying, whatever is the value will be there, like the result that we will be getting is, suppose this is the F1 and this is the F2. So after multiplying these two, the output that we will be getting is only in this range. So output that we will be getting is only that part, because this is F1, this is F2. So we have transmitted the signal this, but we are receiving this. This was the transmitted and this was the receiving signal. So this is not the one that we have transmitted. So there will be some disadvantage, or this we will not be using it. So basically, so we will not be using this practically. So instead of doing that, there is some other process that we will be adopting. So that is basically given here, is like if the available channel is a band pass channel, means if available channel is this type of channel, band pass, okay, then we can't send the digital signals directly to the channel. We can't send this digital signal directly through the channel. We will be doing some processing. So we need to convert this digital signal to an analog signal before transmission. So we need to convert this digital signal to an analog signal before transmission. So we should be converting this digital signal to an analog signal. So before transmission, so that if it is an analog signal, its frequency will be starting with 0 to something, or we will be making sure, like if it is an analog signal, we will be able to make sure like this will be the carrier frequency, and this pattern, that pattern was there for the signal, that will be converted to an analog signal, and now we will be having F1 and F2. In between F1 and F2, this will be the carrier frequency, and we will be able to convert to an analog signal, and that analog will be band limited, or there will be band pass type of signals will be there. It is going to convert the signal into band pass type of signal. So now if this type of signal is there, then it will be able to send it. There will no clipping of different frequencies. All the components of the frequencies will be available into the output also. So we'll be easily able to recover the input signal from the output that we have received. So for that, there is a technique that is called modulation. So for conversion of digital signals into analog, that is basically called the modulation. So here there is a digital signal, okay, that is the input signal. So we will be doing some conversion type of system. So this digital to analog converter will be there. That is called basically the modulation. So we will doing the modulation. After modulation, we will be having converting. So this was the signal that is having the frequency representation was like that. This was the frequency representation starting with 0 to some frequency are going for like up to infinity. So this was the case. But after conversion, you can just see after conversion to analog, the frequency components, this frequency components is now ranging from F1 to F2. Okay, so this is the converted input signal. So this is converted to an analog signal. This is the signal that is converted. Its frequency is now becomes between F1 to F2. Now this is going to be sent from the system, that is channel, bandpass channel, bandpass channel. So now F1 is there, F2 is there. If we go to multiply it, so again the same. If we multiply these two signals, this one and this one, we will be getting the same signal, F1 and F2. So in multiplication, we are only thinking about the frequency. In amplitude also, suppose this is the amplitude is 1 and this is amplitude is A. So after multiplication, the A multiplied by 1, that will be having an amplitude of A. So this is the what the input signal was there. So we will be able to receive it. F1, F2 will be the bandwidth range frequencies, lowest and highest frequencies. So whatever we have sent as an input, we are receiving as an output. So now we will be again converting from analog to digital, and then the digital we can recover at the output or the receiver. Basically, this is the receiver and this is the transmitter. So this is like called modulation. So there is a requirement of modulation first of all. So modulation is required. So we'll be doing different types of modulations. Like this is basically digital to analog conversion. So similarly, digital to digital conversion is also required. Analog to analog, analog to digital. So there are different types of conversions. We will be going through it.